And do any of you have any queries, any doubts from previous sessions? No? Okay. So we'll continue with our DVWA. And I'm just waiting for my VM to boot up.
Sir, what is the password to access the file?
It's asking you for a password.
Yes, sir.
This is yesterday's, right?
Yesterday and I also want of Tuesday, 6th October.
Just always get that eerie feeling that I've left something.
So Tuesday, this is the one.
Something else supposed to find.
Okay, it's asking for just give me one moment. I'll take the settings for this.
Is my screen visible right now? Yes. This Ali's screen is visible, right? Now,
Let's check the settings once again because I'm pretty sure I removed the passcode thing. For yesterday's link, just give me a moment. I'll get it to you. Try this one. Okay, so it should be working now. It will not give you any password requirement now. So okay, we were on the topic of DVWA.
So that I downloaded the Google Chrome, but Google Chrome is not allowing me to do that checking the upload and all. It's giving error like
Error. Okay, share it.
you are using an unsupported command line flag. Uh, okay. For executing, I used no sandbox. Stability and security will suffer like that. It is, and the page is not working.
Page isn't working.
I opened Google Chrome with a no sandbox.
Okay. Even then, it's not working.
I started with a no sandbox only. So because of that, it is giving. I'll share my screen.
Okay.
Yeah, this. I uploaded and
Okay.
it is giving. I started Chrome like this. Google hyphen Chrome
No
hyphen
sandbox.
no sandbox. That is fine, right?
That is not, yeah, that is fine, but that is not the reason behind this error.
Okay.
Can you take me to that page again? What is the error code? Error 500. Okay.
And yeah.
Let me just check why this could be happening.
It is telling you are using an unsupported command line flag. Hyphen no sandbox. Stability and security will suffer.
No, that's not the error. The error
That
is
is
that
just a warning. Okay.
server is not
Yeah. Okay.
handling our request. Let me check. The reason here. Try resetting the database.
So still same. And in Firefox, I'm not able to see anything in upload.
Firefox is not giving you any output.
Not
And
showing anything.
Chrome is showing you that
Yes.
it's an error 500.
In Hackable, it is showing the directories, but in upload, it is not showing.
The uploads directory is not being showed right. And we check the permissions as well, so definitely that's not something that could be the issue.
Okay.
Right, you check the permissions already. Okay, just 1 moment. So the rest everything is working fine, or are you getting errors on some other
No,
pages as
sir,
well?
and there is no error. That day, like about that something it was showing. Then he did something. I don't remember. Only for that page, that thing.
Only for that page.
Yeah, yeah.
There's a PHP library that might help solve this issue. So try installing that. I've mentioned that in the chat. Unable to.
Sir, are you giving any other command to run
I'm
it?
looking for
Okay.
possible solution.
I did with the PHP it installed finally, but zero remote and 5 it were not upgraded. It's already the newest version. Okay.
No, PHP is, you have already PHP installed. Otherwise, your DVWA would not work. Even what is, you're getting an error using the uploads part, but even the rest of it would not work if you did not have PHP. Okay, try accessing the file that I'm going to mention in the chat. Try running this command. Based on the error logs, that's the best way to find out what kind of issue might be occurring. Probably you'll have to use sudo along with it. Okay, it's telling us that failed to open stream. It's always the same error that is giving us all these times. There is no index.php in that directory anyway. Why is it looking for it? Field opening required base jsparker.php. Okay.
Maybe there is any error in that exe, sorry, index.php only. Need to check.
But even it's not even okay. Yeah, I think I understand what the error is. You have to try changing the name of that file from index.php. Try changing it to something else, like just anything but index. Try writing index 1 or index 2. I think that might be the error in this case. Just rename it to anything else. Okay. Try that. Now try accessing it from your browser. No, just try accessing the directory first, the uploads directory. Try accessing that. So that's what's giving us the error. This file we can upload later and see. Still the same thing. Okay. Remove that file from the directory. Make sure you remove it. That index.php file from the uploads directory. Go to the directory either manually or through the command line, and first remove that file. Remove that file first, index.php that is already uploaded. Then upload it with any other name.
Sir, give me that path where somewhere is there.
Path for the folder. Okay.
Yeah. Yeah, got it, sir.
So I've also mentioned it in chat, the path where www.html. Yeah, that's the path. Go and check whether that file is still there. Okay, it's still there. All you need to do is remove it now. Yes. Why? Okay. Now access that uploads page from your browser. See what it tells you in this case. Okay. So it's visible again. The name of the file was causing an error actually, because index.php is usually the first file you expect to open in any what's called in any domain or in any directory. So it was trying to open that and was unable to do so. Okay, so that's why we were getting that error, and when we looked at the logs, then it became clear that that's why it was not working.
Yeah.
So now let's come back to our DVWA. Let's continue from where we left off yesterday. And CSRF, I think I need to start with, right? I haven't covered CSRF yet.
No, sir.
Okay, then we'll That's what we'll continue with. Now in cross-site request 4G or CSRF, what you try to do is you send a link to an authenticated user of a web application or a website, and when he clicks on that, some unintended action is performed, like changing the password in this case, or it may be deleting the account, or transferring funds in case we're talking about bank web application. So since that user is already authenticated on the website, if he clicks on the link and that request goes to the website, it is going to consider that as legitimate. I'm going to show you what I mean here. We'll create a page. Okay, so it'll be like a fake page. We'll create a very small fake page, and it will say that if you click on this link, you'll have a chance to win something. But actually what we'll be doing is we'll be changing the password. So let's see how that happens. First I need to create a new HTML file. And basically now what I need to do is, okay, the first thing I'll add is a couple of things that are basically necessary for any HTML document. So, okay, let me just check whether I'm doing this right. Yes, okay. HTML, HTML again. Actually, a little indentation helps. this case. Okay. So we'll just give this as a title. Now for the body of the HTML page. Now every HTML page, every web page is divided into two parts, the head and the body. The head contains information like the title, or it could contain links to all the scripts that it may load, or to the CSS content, or other kinds of metadata. And the body is what contains the main data present in the page. So now what I need is this form. First I'll click on view page source, and this form that's present, which contains all this information, these input fields and the submit button. I'll copy this, paste it here. Okay, make a few changes to it. So I'll remove this text, new password, same here. Then again same thing. Now currently these input fields are of the type password, but I want to change this to hidden. I want to hide these input fields in the page that I'll show the user now. So again, hidden. I want these to be hidden input fields. Okay, maybe we add one break here. Doesn't matter. Okay, these breaks are already there. I'm not adding any more. And again, both of these are hidden fields now. Autocomplete doesn't really matter in this case. Let's just keep it simple. These are the names of the parameters that are passed through these input fields. Now we cannot change those because those are the exact names that the server is expecting. But in the value field, I can now, I'm looking at this from the attacker's point of view. So if I'm crafting a malicious web page to try and get the user to click on the link I send and effectively change their password, now I have to specify here the password that I want to keep. So the new password, the changed password, what that will be. So I'll simply use new pass. Okay, so this will be the new password. Value is equal to new pass, or just say uh, new pass 1. So this is the new password value that I want. Input type is equal to submit. Now we need to change the text for the submit button. I can't let it show the word change. So for the submit button, the value parameter actually modifies what you see on the button itself. So currently the value is change. So this button says change. Now I want to change the value. Click here to win. Now this is just an example. Click here to win $500. It could probably be as sophisticated or as primal as you want it to be. The page that you send to your attacker, to your victim, basically, as the attacker. So this is the simple HTML form that we're going to use, and let me just end this here. Now there is one more thing that's still left to change here, and that is we need to specify where these values are going to go when we press the submit button. So that parameter resides in this form action is equal to, and okay, if I try changing the password, let's say I just keep the password as A and then A. I click on change. Now see what will happen in the URL. This request is submitted to the URL itself. So it's a get request that's going. Now I need to submit these values to this address. I'll copy that. And here I'll write that. Okay, this I'll just paste here. So when we submit these values, form action parameter specifies where to send the submitted values. So it will send this to this 127.0.0.1 DVWA vulnerability Csrf. So I'll save this web page. Now let's try opening it in our browser. Let's see what this is the one. Open with Firefox. So, okay. So this is the page, and it's simply showing us a button. Click here to win $500. Now we've really kept it very simple, just one button. Of course, you can edit this page, you can make it however you like, however lucrative you want your page to appear. That's up to you. Now, okay, the title says enter the contest. Now if you actually host this page somewhere and you send the link to your victim, now what happens is they are already authenticated to that website. So if they click on change the password, now actually they're not wanting to change the password, but this link does not enter them in any contest. It's actually sending a change password request here. So let's see how that works. If I click here, so it took me to this page and told me that my password has changed. And take a look at the URL, password underscore new is equal to new pass1, which is the password I specified in my Csrf page, the page that I HTML page that I created for this stuff. And same value is here in the confirm password field, and change is equal to the value that we've given. Click here to win. So this is basically how your Csrf works, that you create some malicious link, send it to the attacker. When he clicks on that link, a request will go to the website which will perform a malicious action like changing the password in this case. And now since the attacker has specified the password, he can basically get access to this person's account. So this we have currently been able to do on the low security setting. Let's try changing it to medium and see what happens. Let's see. It's medium now. Okay, medium. Okay, let's access that page again. If I click on this link now, it is going to tell me that that request did not look correct. So it's saying that there's some issue with the request that we're sending. So basically what I can do is I can compare the two requests using burp suite. I mean, of course you can also do that manually, but burp suite has a handy tool built in for this kind of stuff. So we'll start burp and use that to compare these two requests.
So for me, that CRF page is different. It is showing me that change your admin password, test credentials, then new password and confirm password is there.
Change your admin password. So basically, this page.
CSRF.
Yes, okay. Csrf.
Yeah,
The
yes.
vulnerability page is this itself. What else is it going to do?
Yeah. About this change your admin password, I have a button for test credentials.
Test credentials.
If I click that button, I'm getting test vulnerability CSFR and username. It is giving admin and password and login. It
Can
is
you show me
asking
your
me to.
screen?
I need to log into this.
Can you show me your screen once?
Yeah. You need to stop.
Yeah. Just- Okay,
Can you
when you
see
click
my?
on test credentials, what is it giving you? Vulnerabilities, CSRF, and okay, test credentials. Okay. So it's basically just another login box that you can check what your current credentials are. You can try to log in with your current credentials. Instead of having to log out and log in again to check whether the password has been changed or not, they've added a like new functionality which can simply allow you to test whether the password is changed or not. It's just allowing you to test what your correct password is.
Okay.
Nothing to worry about.
So it is allowing me to update also. Change
That's
that
just your
password.
browser. That's your Firefox. Your browser asks you to save password, right? So that's
No
what it
update. It is telling. Would you like to update this login?
update as in it has stored the previous value. It's asking you whether you want to update this
Okay.
to the
Okay.
new value.
Okay.
That's Firefox asking you, not the website.
Okay. Okay.
Okay, so the screen is visible currently.
Yes, sir.
Yes. Okay. So when I click this link, okay, yes, okay, it tells me that the request did not look correct, and we were going to compare the two requests. But where is Bob Soup? Okay, so we have burp suit running now. Now what I'll do is I'll go to this page once into the contest, switch on, tell my browser to use burp as a proxy and press this. And what I'll do is I'll send this request to comparer. Comparer is another tool within burp suite and it will help us compare two different requests. So now I'll actually, even if I forward it, there's no harm.
Sir, in Foxy Proxy, I'm not able to see the burp.
You have to configure a setting yourself and name it burp, or you can name it whatever you want. Because
How I need to
go to
set?
options,
Okay.
add title. I've added burp. You can add whatever you want.
Okay.
IP address type is HTTP. Don't change that. IP address is localhost because of course we'll be running it on your own system. Let's take one extra dot here. And port is 8080 by default for burp suite. So just make these two changes: 127.0.0.1 port 8080 and whatever title you want, and then save it.
Okay.
So then it will appear on your list like with burp or whatever you name it.
Okay.
So currently I've instructed my browser to use that burp setting. And okay, let's change our password via this form. Click on change. Okay, I turned intercept off so it didn't intercept. So now it's intercepted in burp. And let's send it to comparer. Drop it. If you drop it, the request won't go to the server and you will get an error on the page. But that should be expected since you dropped the packet. Now I'll go to the comparer tool in burp, and it has automatically selected item 1 and item 2 as the two different requests. And let's compare them by words. Okay, so these words that it has highlighted in the first line, these are just your different password values in the fake page and in the actual page. So that's of course going to be different because we mentioned different values there, so that's to be expected. But the one main line that is different is this referrer. So referrer is an HTTP header which specifies the previous page. So it's sort of, like what page referred you to this page. So what page did you come from? The previous page that you visited before requesting this page. That's the content of the referrer header. And mainly you can see that that's the only difference here, apart from of course the password values. Otherwise everything is the same. So let's try adding this to our actual content, to our request that we make from the fake page. So let's go to proxy and go to this page again. Now with burp again, intercept this request, and I'll simply add that referrer here. And I don't even need to add this entire thing. I can simply, even if the referrer is DVWA vulnerabilities, even if it's just DVWA, that's also fine. You just need it to be the same IP, the same host. Click on forward. Now see, our fake page was able to change the password when we added the referrer. So if I take a look at the source code, the first thing it's doing is checking for the HTTP referer header. So if that's not present in your HTTP request, then it's going to tell you that the request did not look correct.
So the comparator, I didn't understand. Like you, how it will take two different items for a comparison. It will take a previous one.
Okay, see what we did was, first I sent a request from this page. So I intercepted this request. So this request intercepted by Burp, right click, send to comparer. Okay, now since we have already sent two requests before, so this is the third one that's showing up. Okay, I'll drop this for now. And I'll take a request from this page. Intercept is on. Change. And now I'll send this one to comparer as well. So now comparer has 4 requests since we've sent 4 requests already. Now it will ask you to select the two requests that you want to compare. So the first one is this request 3, and the second one that we want to compare is request 4. And then we simply click compare words, and we do this kind of comparison for us.
Yeah, got it.
Okay. So that is how your CSRF or cross-site request forgery works. Okay, then next level, try it out by yourself first, and then we'll then tell me what you get. Okay, the next thing I'm going to go to is cross-site scripting. We are still medium level. Okay, slow. Okay. Now in cross-site scripting, what we're doing is we're trying to inject some malicious code, malicious script, and we are trying to get the web server or the website to execute that malicious code that we inserted. So with a cross-site scripting attack, when you see any input, okay, when you see any field which is taking input from the user, you try to get it to execute some code. Now, of course, this code may or may not be malicious. That depends on what the code is doing. But of course, if it's an attack, a cross-site scripting attack, if a hacker is making use of it, then of course they'll be using some kind of malicious code. Now, coming back to this, it it's asking for your name. Let's say our name is Harry. So what it does is it simply says hello and adds Harry to the end of that. What if I wanted to try something and make this Harry appear bold? As in, when we do bold or italics in formatting. For bold, we use this. In HTML, this is B, the tag used for bold text. Let's try, see whether it works. So it's working. Hello is normal text while Harry is coming in bold, since we were able to get that tag executed. Now this is functionality that shouldn't be happening. Okay, we should not be able to execute HTML code here. We should just be able to provide a normal string input and that's it. But we are still able to execute some code. So that is, of course, a vulnerability. And not just this, we'll be able to do other things as well. So let's say I want to, try other kinds of scripts. Let's say I want to run some JavaScript here and try that. Script alert one. Now what this will do is it's a small JavaScript code which will raise an alert on the screen and the alert will simply say 1. Okay, so that code is also being executed here, which should not be possible if you should not have this kind of code execution possible on your server. Otherwise, it will cause serious issues. But since, of course, this is a vulnerability that we're looking at, let's see other ways. You can make it say anything you want, not just alert 1. You can make it say hello, submit, and it will say that. You can also use this to show cookies. So this is the cookie that the server is storing on our system for our particular session, so that we are able to see with the help of alert document.cookie. IP address would also be visible in this case. So instead of document.cookie, location.hostname is what we are going to look at. That's given as the IP address. Currently, of course, everything is being run on localhost. So that's the IP. If you send this link to someone else and you make your script so that it returns the result to you, then you will get their IP address as well. So currently what we're doing is we're seeing different types of cross-site scripting payloads. There are lots and lots of different types. If you look it up on GitHub, you'll find long lists of cross-site scripting payloads. Okay, let's look at a couple more. One is using the image tag. So this image tag is used when you want to add any image to your HTML page, to your web page. And after that, you specify the source for that image. So whatever URL, wherever that image might be located, you specify that in the source parameter. But since we are not really specifying any image in our case, we just want to perform some cross-site scripting. We give the source as X and code on error is equal to alert ds. And close this. So basically what this line is saying that I want to load an image. The source is X, so I'm not providing a proper source. And I'm saying that in case there is an error loading the image, execute this code, do this. So it will run an alert document.cookie. That alert is this and contains the value of the cookie stored in the browser for this session. Close. And you can see there's a broken image symbol here. Of course, we didn't actually load any image. We just wanted to run this alert. So this is, we are able to perform cross-site scripting here. And this is the particular kind of cross-site scripting we're looking at. It's called reflected cross-site scripting. Why reflected? Because whatever malicious script we are sending, that is reflected off of the server to the victim's browser. And that is where the result of the script will be visible. Or not necessarily the result of the script. I mean, the victim may not even know that the script has run, but that is where the script will run within the victim's browser to whom we are send the link. So this reflected XSS or reflected cross-site scripting is, that's the name, because your payload is reflected off the server and into the victim's browser where it is executed. So if I'm sending this link to someone with a malicious cross-site scripting payload, it will only execute on their system. It is not going to change code server on the server's end. It's not going to change code there. Now this is, we have looked at low level reflected XSS. Let's try changing the security level from low to medium. Coming back to XSS. Let's try the ones that we've seen before. Script alert 1. Let's see whether it works. It does not work. So the script tag that we entered, that has been stripped off. And we are only left with alert 1, and it's simply displaying that hello alert 1. Let's try something different. Okay, first let's take a look at the source code, see what kind of input validation is being done, so you'll understand why script is not working. So in this line, when we are getting the input, they are replacing the word script. So this whole thing they are replacing with empty space. So let's try something else. Let's try it in caps lock, or in, sorry, uppercase, not in caps lock. And since they aren't actually doing anything with the forward slash script part, you can simply let it be. Try submitting. Now again, it's working. So they added a very weak and very basic form of input validation, which we were able to bypass. And of course, our other payloads, okay, I haven't talked about one payload yet, body on load. So this is basically a way of saying that when the HTML body loads, when the body of the page loads, then execute this code. So body on load is equal to alert one. This is also going to work here. So again, we've managed to bypass their security level. Let's try. Let's try whether we can do the same thing again or not. Mistake. So this is not working either in this case. So they are replacing any occurrence uppercase or lowercase of the characters involved in this word script, and they're replacing it with empty space. Let's try whether our other payloads work. Image source is equal to x and on error is equal to alert document dot cookie. Let's try submitting that. So this is working. Image source and all, that's all working here. Would we be able to do that here? So all of that is not going to work in this case. I'm simply going to use that, and it's going to remove anything else from there and take your entire string as an input. It will treat this entire thing as a name rather than executing anything. So we treat this as a string. So in this case, you will not be able to run your cross-site scripting attack, the reflected one. Now let's change security level again, low for the next one. Let's just clear this. Now this is stored cross-site scripting. This is slightly more serious and a more critical vulnerability compared to reflected cross-site scripting, because in this case, you are able to store your cross-site scripting payload into the database of the web server. So whoever will access that page containing that data, your cross-site scripting payload will run on their page. So this will affect many users, everyone who accesses the page. How that works, let's see here. Name, let's try, let's see if we can insert a script here. Script, and it won't let me any more characters. Let me enter any more characters because there might be a limit here, the maximum length. So we'll look into this later. For now, we'll just name Bob. Message, let's try entering a payload in this case. Script alert document dot cookie. Let's see. Okay, so our payload is working and it is stored here. Now, of course, since it's a script, it's not going to show up as text, but whenever I visit this page, it is going to run. No matter how many times I visit, this script is going to run. Even if I log out and log back in, this is going to run every time. With reflected, it is only going to run as long as you keep using the malicious link again and again. But with stored, it's stored on the server side databases. So it will run for everyone who accesses the page. That's why stored cross-site scripting is more critical and can cause more damage than reflected cross-site scripting. And there are also alternate names for these. Stored cross-site scripting is known as persistent cross-site scripting because it persists. It can, go on for as long as the database contains that payload. and reflected is known as non-persistent XSS. So non-persistent cross-site scripting because it does not persist for a long time. Now, low level, we are able to execute our payload. Let's see from medium level what happens. So our code from before is running. If I clear guessbook, that value is going to be deleted. Okay, so it's deleted now. Now let's try doing the same thing. In this case, it does not work. Let's try other kinds of payloads. This is not working either. I come back to this page now and then it's not working. If I take a look at the source code, you will see that they are sanitizing message input. They're applying all kinds of checks to it. But for the name input, not much is being done. Just this thing script is being replaced. So let's try attacking the name input. But the thing is, here is I can't type anything more here. There is also a way to get past this. Can anyone suggest what we might do in such a situation?
Sorry, sir, what did you ask?
I'm saying that in this case, it's not allowing us to enter any more characters here, right? There is a way to bypass that. Can anyone tell me how I'm going to bypass this limit of entering characters?
By executing the max limit of that, is it possible? But it is not allowing me, right?
Could you please come again?
I said like anyhow it is allowing us to execute the script so we can increase the max size, but it is not allowing, right, to enter itself.
So what do I do to increase the max size? I'll simply open this, inspect that element, this particular text field. So it says here input name is equal to text name. Okay, take a look at this one. Type is equal to text, size is equal to 30, and max length is 10. This max length is the issue. I simply remove that. Now it will let me enter anything I want. But we saw that it was removing script, the word script outright. So I can simply try this. So our payload is running again in this case, and we are able to bypass whatever input validation they have placed here. There is yet another way to do this. Can anyone guess what that is?
As you executed with the body, that we can do here.
Body, no. They have properly sanitize any input that goes into the body field. So that is not a possibility now. We only have to target this one, name field. No? Okay, think about it, and we'll discuss this tomorrow when we continue with the chapter. There is another way to bypass this maximum length. One is, of course, you change it in your browser itself. There is yet another way to do this. And you are already familiar with the method that is used, so then try to guess what we will be using. So think about it. We'll,
Yes.
of course, I'll show it tomorrow.
Yeah. So for message there in source code, we have seen that only they have used a script. They have put a validation on for a script. So we can use body here, like how we have used body and
No, no.
on.
For message, they will not allow you to use anything. Let me show you. Load is equal to alert, let's say 10. Close this. But this is not going to work. This 10 is from the okay, wait. No, this should not be working. Did I try image earlier or what did I try? Let me just clear this. We can try this again.
You have
So
not
this is
tried with
working.
him.
That's also a way. Name is A and body on load. If this works, then good. We have more ways to do this. But if this is working, it means that even that input validation has not been applied properly. Well, let's see. Now it's not working. That was from the previous alert, the 10 that we saw earlier. Let's try if this works. No, so this is not going to work because they have applied a lot of checks on this message part. So we only need to target this. So try to think about what other method we might use for that. And I'm going to, of course, discuss that as a first topic in tomorrow's session. So that's it for today. Are there any questions, any doubts that you would like to ask, anything that you would like to get clarified? No? Okay then. If you don't have any other questions, you are